Hello everyone. Today let's talk a little bit about music theory. And I have a few disclaimers before we begin. First, there's like two different types of theories. There's descriptive ones and there's prescriptive ones. Descriptive theories try to observe the music that is actually out there, that people are listening to, that people are creating, and trying to find theories to better describe them and understand them. That's not what we're doing today. We're using prescriptive music, where we basically create some rules and try to create music based on those rules. This necessarily gives us restrictions to what types of music we will be able to make. And this is, well, far from ideal in some cases, but it will do for us. Second disclaimer, we'll be using strudel, but this is not a strudel tutorial because I absolutely have no idea what's going on there. So find someone who actually knows how to do a strudel tutorial and follow them. And there was one more disclaimer. Oh yes, okay, so when I will say something that sounds good or that it sounds bad, especially if I say something sounds bad, that doesn't actually mean that it is wrong to use it. In the context here, bad will be things like the tritone, which is a very clashing sound, and that kind of clashing sound can be precisely what you need in some music. It can be just the right spice for just the right place. But generally some things will sound more natural to our ears and some things will sound quite unnatural. And it's just knowing what you have to work with that is useful. And it's useful to have a balance of things that sound good and the things that don't sound nearly as consonant, that has some dissonance, to add some variety to your music. Okay, so first things first, what are we going to talk here? My goal is to talk about some pretty crazy theories, but to get to them, I will just cover the basics for everyone here. And I'm pretty sure that if you stick to the end of this, you will learn something you hadn't learned before, even if you went to music school. But everything begins from the beginning, and when it comes to sound, that means sound waves. So at the most basic, sound is waves that vibrate through the air, and through mathematics we know that the sine wave is very nice, and every single other possible wave that exists we can kind of write it based on sine waves. So here is what a sine wave sounds like. It's not necessarily the most pleasant sound, but it's like a hum. And the thing is that when you have one of these waves, there's a couple of things that are useful to know. One of them is the amplitude, and the other is the amplitude is how much the wind moves, basically, and that is going to be related to loudness and volume. The other thing is, well, how long the wave is, or more interestingly, how often does the wave occur. That's going to be related to the frequency and to the pitch. And so here I have C3, which is one of the notes we can play. I can have C4, which is higher in pitch, and it will sound like this. And as you can see, it is more narrow. Or I could have C2 and it will be wider. Yep. Okay. And now one of the things is that the pitch is going to be something that can be higher or lower. Lower pitch is when we have wider waves. Higher pitch is when we have narrower waves. Yeah. But then we have some interesting things. So if I have my wave like this, I could have another wave that is twice as frequent. And they will generally sound nice together. So for example, I have my C2 and I have my C3. Let's see how that sounds. So that sounds nice, but if we put them together, we get this. Yeah, so it's a nice pattern. And we can even add C4. So this would be an even shorter wave, now 4 times as high. And that sounds nice. That sounds nice. And what is happening is that it starts sounding less like a sine wave and more maybe like an organ, for example, in this case. And what's happening is that every different instrument will have, it sounds different, right? A piano and a guitar will sound different from each other, and they will sound different from organs or human voice. And part of it is what we call the harmonics. And so basically you have your base frequency, which might be this green one, but you would also have a few extra higher frequencies, which would be the harmonics. And these harmonics will change based on the instrument, and they're going to be what determines what the instrument actually sounds like. There's other things like how quickly the volume increases when you attack, or how long it takes for the volume to like come down after you hit the note. But so what do I mean by harmonics? Like maybe 2 different instruments have the green, the blue, and the red wave, but one of the instruments has a much bigger red wave compared to the other one, right? That would change the harmonics. And so, for example, you could have something that looks like a square wave. This is used in chiptune, for example. And this would have some very different harmonics compared to a triangle wave, saw wave, sorry, also used in chiptune. I won't put them, you can look them up. But the way we get these ones is you just have a sine wave and you get more sine waves. But the recipe of which sine waves you combine, that gives you a different kind of final wave. Okay, so the question is, what are the harmonics that are useful? And usually these are the rational things. So definitely when we have something like a 2. And what is happening is that harmonics are so common that for us, these notes will sound the same. So C2, it sounds lower than C3, which sounds lower than C4. But somehow our minds still feels like it's the same note, just at a different kind of like place. And so that's the concept we're going to be using, which is that octaves, which is notes that are separated by twice or like 4 times, they are basically the same. So C3 and C4, they're both C. They're just in different places. And that's going to be useful for when we start looking at different pitches. And the actual like number we're in is going to be important music-wise, but for this kind of theory we'll be looking at, we'll mostly be concerned ourselves with C. Okay. But if we try to do everything with just C, then we can do some interesting things, but we can't do all of modern music, right? So we need the other notes. How do we get them? Well, what if we add 3? So if this is C4, thrice this wave, it would be what is G, sorry, if this is C3, then it would be G4. So if I have like, this is my C3, this is my C4, and this is my G4, and this is my C5. So this is times 1, this is times 2, and this is times 4. So what is times 3 is going to be something between C4 and C5. And so this is what they sound one after the other. Yeah, and this is what they look like together. And as you can see, if I stop it, it does look like G4 is like happening 3 times for every time C3 is happening. Yeah. And so this is a sound that we like a lot, and this is what we call the 5th. And of course what we can do is we can bring G4 here, and so now we have our G3, which is times 3 over 2. And this is what we usually will call the 5th. And so that's going to be C3 and G3, which will sound like this, which is quite a nice little wave. And when we put one next to the other, they will look like this. Okay. And so the question is, well, what can we do next? Well, what we could do next is just continue. And so what is the 5th of G3? We can just multiply by 3 over 2. And so we get 9 over 4. But then again, this will be somewhere around here, right? So we can bring it down and we can get 9 over 8, which is very close to 1. And that's because it would be around here, which would be my D3. Should be 9 over 8. Okay. And so we have our C3, our G, and then our D3, and we can continue going around. And this is what we call the circle of fifths. Yep. Let me draw a circle. And so we're going to have 12 notes. We will choose C to be our first note. And then we were going to create the one that comes after, which is going to be a fifth up. So it's going to be G. A fifth up is going to be D. A fifth up, it's going to be A. And if you don't know these notes, just know that we are creating them one by one. And you can think, oh, what is D? D is just the fifth of G. What is A? That's the fifth of D. What is the fifth of A? That would be E. The fifth of E should be B. And C should be the fifth of F. And that gives us all of the nice, so if we have like a piano, we have like white notes and we have like black notes in between some of the white notes, but not all of them, because some white notes will have no black notes between them. And so this one already gives us the white notes on the piano. And this one's here are going to be the black notes on the piano. And this was going to be F sharp. And here we have what would be B flat. And if we start with F sharp, then we get C sharp. That's the fifth of F sharp. And we take B flat, then we get E flat, right? And finally, we get here. We can go down from here and get A flat. And so E flat would be the fifth of A flat. Or we could go up from C sharp and we get G sharp. And the thing is that these two things in our pianos, they are just the same thing. They are what we call an harmonic. Or two different ways to write the same thing. But we don't have a piano. We have been constructing the notes by using fifths. And so it doesn't make any sense, right? Because what we are doing is we keep multiplying by 3 over 2. And we keep multiplying and multiplying by 3 over 2. So no matter what we do, we have 3 to the power of something divided by 2 to the power of something. And that's never ever going to be equal to 1 unless these two are 0, because 2 and 3 are co-prime. So what is actually going on? Do we actually have a full circle? And the answer is no. What's happening is that these two notes are kind of very close to each other, but not quite the same. So if we build the notes using the circle of fifths, we actually don't get a perfect circle. We kind of get to some weird point that is two varied notes that are very close to each other, but not quite the same. And that's because of a fun fact. What is 3 to the power 12? Well, that's something I know by memory, and by that I mean I will use a calculator right now. So 3 to the power 12 is 531,441. And what is 2 to the power 19? Well, of course, that's something everyone knows. That's 524,288. And the thing is that these two numbers are very similar to each other. They're like massively different if we think of them as like numbers. They differ by 10,000. But if we take one divided by the other, well, that's something that is very close to 1. And so that is what is happening. If we construct the notes in this way, well, we get 12 notes, except one of them is kind of 2 of them, but we kind of fudge them together because they're close enough. And so what we do with the piano and with a lot of modern instruments is, instead of using just intonation, which is creating notes by using the circle of fifths, what we're going to do is use what is called a 12th tone equal temperament. And so our ears, they like rational sounds. Like if there's a wave, we like it when there's something that is twice that wave, right? And we like when there's something that is 3 times that wave. 3 times that wave, right? But sometimes things get close enough and our ear is okay with that. And especially if it's something that we hear often enough, because music these days is basically all written in 12th tone equal temperament, then it is something we are used to and it's something we are happy with. So what does equal temperament do? It says, well, here is 1, here is 2. How do we split all of these evenly? Knowing that after the 2, there will be like a 4, and after a 4, there's going to be an 8. So it's not like we can just split this and say this is 1.5, right? What we need to split this is say that this here would be the square root of 2. And so if we want to split the interval from 1 to 2 equally with different temperaments, what we do is we say that, well, we start with 1, then our semitone, which is the like 1/12 towards 2, is going to be the 12th root of 2. And then the tone is going to be the 12th root of 2 squared, and so on and so forth. And just let's look at the numbers. So this is the Wikipedia page for the 12th tone equal temperament. And here is the comparison with just intonation. And what we have here is that 3 over 2 is very close to the 7th element in this sequence, to 2 to the power 7 over 12. It's going to be very, very close to 3 over 2. And it just so happens that many of these other elements are also very nice numbers. So this one is very close to 5/3, this one over here to 9/5, and this one over here is very close to 45/32, which, let's be honest, that's not as nice sounding. And that's because this one here is really just the square root of 2, and that's not really very rational, if we are saying that. And so some of these notes in our 12 notes are gonna sound nicer because they're close to a very nice fraction, whereas other notes like the square root of 2, well, that's not very nice, that's not very rational, so it's not going to sound as nice. Okay, but that does bring us to the intervals. And yeah,